I am the tutor for the Native American Center and building the Ollie Center. Sorry about that. I am going to be talking to you guys about some of the notes we've been taking and some of the experiments he did in class with us. Unfortunately, I don't have a video or anything like that to show you over the experiments, but we'll see how this goes. I will not be writing anything on the smartboard today or typing anything out for this kind of reason. I can't really. And I would be showing you my notes, but kind of just atrocious. Don't know what that means? It means very bad. So we started Tuesday. If you missed, we started Tuesday with just getting to know some more things about the periodic table and the elements on the periodic table. So chapter 10 is the one we started. He showed us an example with chlorine and sodium. And he explained to us that if you lose an electron on a element, then that's going to make that element a positive ion, which is also known as a cation. And then if you gain an electron, the ion will be negative, and it is also known as an anion. It's like anion. He also explained to us that there is a rule that says you cannot gain or lose more than 3 electrons. So if you're trying to make one metal into something else, and it means, or usually everything wants to be a noble gas. So if you're trying to make an element into a noble gas, and it takes 4 to get added onto it, but it only takes 2 to make it a noble gas, then you have to go with 2 because you cannot add 4 electrons to an element. It's a rule. We talked about different kinds of solutions. There's heterogeneous, which is not uniform throughout. So if you had a sand and water mixture, then the sand and the water they're not going to mix exactly to the perfect amount. So you may take a spoonful of one, put it in a cup, take a spoonful, put it in a different cup, and you could have different amounts of sand and different amounts of water in each of the cups. No matter how many times you do it, the likelihood that you would get exactly the same of both sand and water in 2 different cups is very, very slim. And that is what makes it a heterogeneous solution. If it's a homogeneous solution, it is uniform throughout. So like salt water. If you mix salt and water, the salt dissolves into the water. And when it does that, then you can pretty much take a bet that if you took a spoonful of the salt water and you put it into a cup, and then took another spoonful, put it into a different cup, this amount of salt and water in both of those cups, or however many cups you put in there, should be exactly the same. Or if not exactly, so little so that you wouldn't be able to tell the difference no matter what test you ran, basically. So another way of saying that is it is uniform throughout. And no matter how many times you do it, you'll always have the same amount of salt and water. So that's a heterogeneous and a homogeneous solution. He gave us the definition of a compound, which is 2 or more elements combined together in a fixed ratio. And then a mixture is 2 or more elements or compounds mixed but not reactive. He explained to us some of the things for the periodic table relating to groups. How you have group like 1 and 2. Let's see if I can pull something up real fast about that. So like this shows there are, this is group 1 and 2. Here, this one might be better. This is group 1, group 2, group 3, group 4, and so on and so forth. And then periods, so groups go vertically, periods go horizontally. So these are in period 1, these are in period 2, these are in period 3, and so on and so forth. And that would be how you identified it. I know this isn't very clear, I'm sorry about that, but basically what you need to know is if you're doing groups, you're going straight down, and if you're doing periods, you're going straight over. He told us about covalent bonds and ionic bonds. A covalent bond are when elements or compounds share electrons. So if you had oxygen and 2 hydrogen, H2O, what they do to make their bond is, because hydrogen can't get rid of the only electron it has. So instead, it shares that 1 electron back and forth with oxygen. And that's what makes a covalent bond. So H2O, water, is an example of a covalent bond. An ionic bond is the transferring of electrons. So in sodium chloride, I hope that's right, they're bonded together because sodium and chlorine are, yeah, I think so. Sodium is positive, chlorine is negative, and so they transfer the electron between them. Covalent bonds only exist between 2 nonmetals, and ionic bonds can only exist between metals and nonmetals. Covalent molecules are polar. You'll need to know that because, oh crap, I forgot to anyhow, sorry. What we covered today was solubility, still part of chapter 10. It's a solvent is what does the dissolving, and a solute is what gets dissolved. So an example of a solvent would be is if you're mixing salt and water is the solvent, is what the thing dissolves into. And then salt is the solute. Sorry, that word sucks, but it's spelled S-O-L-U-T-E, in case you're curious, or in case I'm saying it wrong. And that it would be the salt that's being dissolved into the water. A solution is what is made after the dissolving process. So after the salt and water dissolve into it, or after the salt dissolves into the water, you get a solution. And concentration is how much solute is in the solution. So if you had salt water, the concentration of it would be how much salt is in the water. If you want a higher concentration, you add more salt. If you want a lower concentration, you add more water, and so on and so forth. A saturated solution is when all the solute that will dissolve at that temperature has dissolved. So if I had water and salt, I really wish I had some of this stuff so I could just mess with it. But if I had water and salt and I stirred it together, the salt dissolves into the water. Eventually, if I keep pouring salt into it, the salt will stop dissolving. And that is because at that temperature, that is all the water can, or that is all the solute, salt, that can dissolve into my solvent, something, which is the water in this experiment. An unsaturated solution is exactly the opposite. It means that not all of the solute that will dissolve at that temperature. So if I put a teaspoon of salt into a glass of water, you can add more salt and it will still dissolve, but since I haven't, at that point, that is an unsaturated solution. Because I can add more solute and it will still dissolve. Next section is solvents and how they work. Okay, so polar solvents polar or charges on the molecule. Nonpolar means there's no charge on the molecule. I'm sorry, I'm having a problem with words today. Okay, so something that has a polar charge, I guess, would be water. What am I saying? Sorry about that. Water has a polar charge, which means that it can go to, hold on, let me see if I can look up an example of this. Sorry, I can't write some of this down for you, but it would look trash and you would not be able to read it or even understand what I'm doing. Okay, so water is polar because of the bend shape of the molecule. So, see if they have an image for me to show you. None of these are really what I wanted to show. But basically, like right here, this is oxygen, these are hydrogen, this one's negative, these two are positive. So this hydrogen could connect to another oxygen, and its hydrogen could connect to another oxygen, and so on and so forth. Anyhow, and then a nonpolar example would be grease. So like if you get grease on your hands and you run it under water, usually what happens, it depends on if you guys cook or work on vehicles or whatever, the water will just run off of your hand. It won't even seem like it's touching it. That's because water is polar and grease is nonpolar. And there's a rule. It's called the like dissolves like rule. Polar to nonpolar, polar to polar, nonpolar to nonpolar. That means that water won't get grease off your hands because water is polar, grease is nonpolar, so they basically just repel each other. That's why you use soaps usually to get grease off your hands, because soaps either have one specific purpose where it's like this is a special soap to get grease off your hands, but most soaps are both polar and nonpolar. That way they can work for both substances depending on what you need. So anytime you want to check to see if a substance is polar, like example that Emberton used in class today was like soy sauce. If you get soy sauce on your hand and you put it under water and it rinses off, that means it's polar. If you put it under water and water just seems to bounce off of it, not literally obviously, but that means it's non-polar. So for those of you who don't know, soy sauce is polar. It will wash off your hands with water. You don't need soap for it. Probably should put soap on your hands though, because soy sauce doesn't smell that great. Okay, the next thing is the dissociation of ionic compounds, which means dissociation means that instead of them just what is it called? dissolving. Instead of them dissolving, so like instead of salt dissolving into water, the salt would break up apart into ions, and that would mean dissociation. It does not, however, so it's called dissolving. This is also called ionization for obvious reasons of it breaking apart into ions. Compounds that will dissociate are called electrolytes. So if you had Gatorade, a lot of people drink Gatorade, especially if you play sports or you run or exercise or just generally like it. Everyone knows that they have these things in them called electrolytes. And you need electrolytes to replenish some things in your system and to work, but too much of them is a bad thing. The way you get electrolytes, though, is they mix the water, like when you read the Gatorade bottle, it says like water and sugar, and then a bunch of other stuff. And the compounds in there dissociate, so they break apart into ions, and that's what gives you the electrolytes that you need for whatever thing you're doing. Compounds that will not dissociate are called non-electrolytes. And that's pretty much all about that. Honestly, if you're missing class for a reason that's not necessary, I would advise you to go to Imperton's class because he explains stuff way better than I do. Honest to God. Like, if I had an option to miss his class and listen to me talk, or just go to his class, I would go to his class every time. I wouldn't know what to do with me. And then we talked about acids and bases. Acids, when you're doing equations, I guess they're called equations, I'm not exactly sure, but like adding two compounds to each other. Example would be well, at least now we know that's definitely not what it's called because that didn't pop up. Oh look, it's the thing I was trying to show you earlier. You being the general public, or wherever you are. I hate trying to find stuff on here. Let's see if I can just type you an example. No, that's the wrong thing. Dang it. I'm trying. I'm sorry, guys. Wasting your time a little bit. Anyhow, acids will give up their hydrogen, or their H plus or hydrogen, and bases will accept a hydrogen, which is how you can tell whether something is a acid or a base in a written example, if you don't already know. Okay, so like I didn't write any of those examples you wrote on the board down, but I have okay. So like this. This one is going to be a base, and this is going to be water. Hold on just a second. Sorry guys, I basically realized that I have no idea how to explain this to you in a way you understand. However, you could do what I do, and when I have questions, you can just go up, you can go ask Emerson during his office hours if you don't understand something, and I'm sure he would explain it to you. Anyhow, that's all that we did for this week. So I'm hoping that helps some of you. If not, I'm very sorry. Well, if you need any help on something that I can help you with, although I'm not sure that you want my help, we are at the Naz Natai Lab, or the Native American Center, whichever one you prefer, is located at the top of the OC building, which is the Ollie Center, in room 1318, if I remember correctly. It's been a couple weeks, and I'm still wiped out from spring break, so I'm lost in a lot of my classes. If you need any help, you can just come up, and you don't have to have me for help. There are other tutors up here that can help you with any kind of class you're taking. We have a variety of people. That's all I have for you today. And I'm gonna cut the video short to like right now. Bye guys. See you next week.